about function, it means that a function is a rule which maps a number to another unique number. Especially this, underline this word, a number to another unique number. That means what we are saying that it maps an input to an output. That means a function maps an input to an output. That means the output has to be a unique one. What are we trying to say? Let's say, for example, now we say f of x, a function now, f of x is equals to x plus 3. Now, what we are saying here, the x is what we call the inputs here. X is what we call inputs. And our f of x is what we refer to as output. Input, output. That x can also be referred to what we call the domain. And that output can also be referred to what we call the code domain. Or we say it is range. We say code domain. Or sometimes we use range for it. Now, let's say, for example, now the value of our x, which is input, is 1, 2, 3, for example. Now. So what will be the f of 1 here? When we put 1 there, that means we have 4. F of 2, that means we have 5. F of 3, that means we have 6. Inside this, do you see that to every input, we have a unique output? Not that when I put x equals to 1, I get 4, and also put x equals to 2, I get 4. No. So for every input here, there is a unique output. That's what it's saying here. That it maps a number, that means the input, to another unique number. That means which is the output. So for it to be a function, it has to match a number, that's the input, to a unique number, that's the output. Not as an input, maybe like 2 inputs, giving us an output that is having the same number. You will see here now for f of 1 is different from f of 2, is different from f of 3. That's what they use, call the unique output. That's to give us a unique output. Now, if you see the rule down here, and if a relation is to be a function, then it must obey these 2 rules. Every element of the domain, that means the value for x, has an image in the code domain. And the second rule, that the image of that element in the domain, they say the image of every element of the domain is unique. The image is unique. Like this now, f of 1, which is 4, f of 2, which is 5, and f of 3, which is 6. They are unique. It's not the same. F of 1 is not equal to f of 2, is not equal to f of 3. But that means that's what it means by they are unique. So under it, there is something we call one-to-one function. Under the function, there is something we call one-to-one function. So in literal sense, what they are saying, one input is equivalent to one output, like this now, like this function now. So every input you are putting to this now, you have a unique output. Not that one input is leading to a two outputs. No, one input is leading to one output. That's what we call by one-to-one function. That means one input is mapped to one output. That is the meaning. Not that when you put to one input like this now, f of 1 equals 4. I now put 2 again, it gives you 4. No, that's not a function. That's not what we call one-to-one function. Example of a function that is not one-to-one, when we have f of x is equals to x squared. Now this is quadratic now. We will see that at the value of x equals to 1, f of 1 equals to 1, and also at s equals to minus 1, f of 1 is also equals to 1. You see now, at 2 different inputs, we have the same output. So we don't call this one-to-one function. Quadratic function mostly is not one-to-one function unless we restrict the input. We restrict the input. What do you mean by restrict the input? If I choose that f of x equals to x squared, that means if I want to restrict the input, I will have to write it in this way that the value for x that we use maybe is greater than or equals to 0. That means I will not consider a negative value for x. So at this point, I've restricted my input, the value for x. Now that it is greater than or equals to 0, that means I can only put when x equals to 0 or 1 or 2 or 3. So by putting this, you see we have a different output for each input. That's what you can refer to as a function. But generally speaking, a quadratic function is not one-to-one function. Now, there is something we call onto function, or sometimes they call it onto mapping, like this onto mapping or function. So in this case now, what we are trying to say is that if different elements in the domain, that means that's the inputs. That's the inputs. Don't forget we use X for our inputs. If different elements in the input, that's the domain. No. What I'm trying to say, if every element in the input, that's our domain, have at least one output in the whole domain. So what this one is saying is that we can an element in the domain can have at least, that means it can be more than one. One is it can also be more than one. That means when we are dealing with an output giving us two values in our codomain, a single input giving us like two values in our codomain. For example, now, if we check something like this, you know, sometimes they use kind of a circle. Let's say this is my domain. I have A, B, C, D in this domain. I'll say that's the value for S. And I have my codomain now. Let me say my codomain is X, Y, Z. So the mapping is if A is mapped to X, B is matched to X, a bit to Y, and C now also matched to Y, D matched to Z. Do you see now? That means what you are trying to say is B and C in the domain is matched to an output in our codomain. Two inputs giving us the same answer in our codomain. Two inputs giving us the same answers in our codomain. That's what we call onto mapping. It's just like we have two inputs giving us the same answer, like that of the quadratic equation that I pick as x squared now. You see that when x equals to 1, we have f of 1 to be 1. And when x equals to minus 1, we have f of minus 1 to also be 1. You see now these two inputs now, two different inputs, giving us the same answer as the output. That's what we call onto mapping. Onto mapping or onto functions. So the next one we look at is what we call a composite function. Now from the word composite means it's an idea of trying to put a function inside another function. We are trying to put a function inside another function. What do I mean? That means in this kind of thing, when we divide two functions, we say f of x, one function, and g of x, another function. So that means if I'm trying to put g of s inside f of s, that means I'm trying to do a composite function. That's the meaning. And this is the way they normally write it. If I say g o f, it means that I'm putting f of x inside g of x, and I will write it in such a way that g into bracket f of x. So in this kind of situation, the function f of x is standing as a x value for g of x. And if I have something like this, f o g, it means f into bracket g of x. That means here, the function g of x is standing as a x value for f of x. That's what it means. For example, let's say we have f of x equals to 2x squared minus 3. And g of x, we have it to be x plus 1. Let's assume that this value for s are defined on a set of real numbers. That means s is a member of real numbers. Now, in this now, if you're now asked to find one, f o g, and 2 g o f, for example now, you will see that what they're asking to do here is a composite function. Anytime you see this, now, number one, there you have f o g. It means that function g is an input to the function f. That means you have f into bracket g of x. So that means g of x is standing as x for f of x. Now, how do we put this now? You can write this as f into bracket. Now, what's my g of x? I will say x plus 1. That's my g of x. Now, what this one now means that if I now go to function f now, anywhere I'm seeing x in function f, I will be putting x plus 1. So that means my FOG means that when I go to function f, and function f is defined as 2x squared minus 3. That means I'll say 2 into bracket. Now, anywhere I see x in f of x, I will put x plus 1. So I put x plus 1 all squared minus 3. I will simplify this one. I have 2 into bracket x squared plus 2x plus 1 minus 3. That will be 2x squared plus 4x plus 2 minus 3. That will give us minus 1. That's the meaning of FOG. That means f of g. If you follow the same trend for g of f, that means we are saying g into bracket f of x. That means f of x is now standing as input here. That means we have g into bracket. My f of x is 2x squared minus 3. So that means anywhere I'm seeing x in g of x, I will put 2x squared minus 3. So that means my g of f becomes, if I go to g of x now, is x plus 1. And anywhere I'm seeing x, I put 2x squared minus 3. So I will have 2x squared minus 3. Don't forget, in g of x, we still have plus 1. And that becomes 2x squared minus 2. That's a composite function. And the next thing we consider there is what we call the inverse of a function. Inverse of a function. Inverse of a function. Now, in this inverse of a function, if you have a function f of x, the inverse of f of x is f, we write it in this form of x. The inverse of f of x is written as f raised to the power of -1 into bracket x. And now, in doing the inverse of a function, you need to follow these 3 rules. The first thing I will say, turn f of x equals to y. That's the first thing. That means anywhere you see f of x or any function given to you now, it might not be f of x. Maybe they define it as g of x or they define it as h of x or anything. Just make sure you just put to turn it to y. The second thing is swap s for y. That means when you turn it to y, anywhere you are having x, put y. Anywhere you are having y, put x. And the third one is make y the subject. That will make y stand alone. And the third one is you now replace y by f inverse of x. This is just 4 simple steps. That means turn f of x to y, swap s for y, make y the subject and replace. For example, now if you are given a function like this, now look at this function. We are given that simple one, if given that f of x is equal to 3x minus 2. 3x minus 2. And then before I proceed with this now, for you to find the inverse of a function, that means the function must be 1 to 1. If the function is not 1 to 1, you can't be able to find the inverse. For example, you might be given a quadratic function like the one we see earlier. But before you can find the inverse of a quadratic function, you must, the domain, that means the value of x will have been restricted. If it's not restricted, that means you can't find the function. For you to find the function, the inverse of a function, the function has to give you 1 to 1. That means 1 input giving us 1 output. If you check this now, at every point of value for x, we have a unique output. If f is 1 here, we have f of 1 to be 1. If x is minus 1 here, we have f of minus 1 to be minus 5. So at every value of x given, you have a unique output. Don't forget that for you to find the inverse of a function, the function has to be 1 to 1. Now, if you also find the inverse of this, sorry. So the first thing, turn f of x to y. That means this is f of x, I will replace it with y. I say y equals to 3x minus 2. Y equals 3x minus 2. So swap s for y. That means anywhere I'm seeing y, I put x. Anywhere I'm seeing x, I put y. That means I will have a x equals to 3y minus 2. The next thing is to make my y subject of the formula. So x plus 2 becomes 3y. So making y to stand alone, y becomes x plus 2 over 3. So this thing says replace y. That means my inverse of x now become x plus 2 over 3. That's how to find the inverse of a function. The inverse of a function. Let's look at one example more there. The inverse of a function. So if you follow that just simple rules, you will get the inverse of a function. Now let's say we are giving something like this. Now, yeah, let's stop it there.